Hello students, today we are going to discuss in detail about the work. As you know already about the formula of work is equals to what? Force into displacement. That we can write work done is equals to component of force into displacement. The component of force that we have taken F cos theta and displacement is what? S. So we can write W is equals to F into S into cos theta. You know that the work is scalar quantity, so we can write it W is equals to F dot S, and it is nothing but what? F cos theta. So what is the definition of work? Work done by force is defined as what? The product of component of force in the direction of the displacement and the magnitude of this displacement, that is known as work. So the work done by the parallel force. Here you will observe the first figure. In that first figure, the force is acting here in parallel direction. So what is our formula? W is equals to Fs cos theta. Theta is what we will take here? 0. So if we will take the theta 0, what is a cos 0? It is a 1. So we can write W is equals to F into S. Work done by an oblique force. Here the force, it is neither perpendicular nor parallel, it is acting obliquely. So in that case the W is equals to what? F cos theta, that is the component of force, and S stands for displacement. So we can write the W is equals to Fs cos theta. So here we have seen these two cases, work done by the parallel force and work done by oblique force. Now let us try to understand the example of work done. Here we have taken one load, the man is carrying that load. Here the F we have divided into two components, one is in horizontal direction and another is in vertical direction. So F sin theta, this is the component we are considering, it is acting in vertical direction, and F cos theta, it is acting in horizontal direction. So here the F, it is resolved into rectangular components. So if we will see F sin theta, the F sin theta acting in vertical direction does not displace the body in that direction. Therefore the work done by the component F sin theta is what here? 0. But if we will see about F cos theta, it is acting in horizontal direction and it displaces the body in that direction. So here you will observe the body is displacing in horizontal direction, and what is our horizontal component? That is F cos theta. So we can write the formula work done is equals to force component into displacement, and what is the force component here? F cos theta, and displacement is S, so we can write it is Fs cos theta. So now let us try to understand here when the work is 0. As you know the formula of work is equals to what? Force into displacement. So for the work to be done, both force and displacement must be present in the body according to the formula. So here if the force applied on body does not produce any displacement in the body, scientifically the work is not done in that case. Here we will discuss some examples related to it. So let us try to understand here. The man is holding a book and the book is in stationary condition. So what happened here? The book acting here, the weight of book acting on him does not produce any displacement. So what happened? If the displacement is not done, the work is what? 0 in that case. So you know that for the work to be done, both force and displacement must be present in the body. A man holding a book in his hand in a stationary position does not do any work, since the weight of book acting on him does not produce any displacement also. So here what happened? The work is 0 in this case. We will see one more example. We have taken a wall. So you will observe here the man trying to push a wall. What happened? The wall does not move here. So is the work is done in this case? No, because the wall is not displacing. The force acting by the man, it is what? Not enough to move that wall. So here work is not done in this case. So here the force applied by man does not move the wall, and because of that the displacement is a 0, and therefore the work is not done in this both cases. So work is 0 in this both cases. Now let us try to understand here. If the force applied on body is 0, scientifically the work is not done in this case. Same like that, here we have taken one example. Here the friction is absent and the body is under uniform motion, but we are not applying any other force on the body. So what happen, if we will not apply any other force on body, if the force is a 0 here, the scientifically work is not done, because work is equals to what, force into displacement. If the force is 0, then the work is not done. So here you have to know, in this case the friction is absent and the body is under uniform motion. Now let us try to understand some points related to the work. So work is which quantity? Scalar quantity. So work, it can be positive, 0 or negative. Let us try to understand about the negative work. Negative work, it does not mean that it is a vector quantity. So work done by the friction is negative. So you have to know, if the displacement it is in opposite direction, so what happened, the work done by friction is negative, as the displacement is opposes to the friction, it is in opposite direction to the friction. So in that case the work may be negative. So you have to know, the work, it can be positive, 0 or negative also. Now let us try to understand the dimensions, that is m raised to 1, l raised to 2, t raised to minus 2. These are the dimensions of work. Now what is the SI unit? The SI unit of work is joule, and 1 joule is equals to 1 Newton into 1 meter. 1 Newton is a unit of a force, SI unit of force, and meter, here we have taken it is for displacement. So 1 joule is equals to 1 Newton meter. So 1 joule, we can write it, 1 joule is the amount of work done when 1 Newton of force is acting on body and displaces it through a 1 meter. So you have to know what is a 1 joule. Now let us try to understand its CGS unit. CGS unit of work is erg. So what is the relationship between erg and joule? 1 erg is equals to 10 raised to minus 7 joule. We can write 1 joule is equals to 10 raised to 7 erg also. Now let us try to understand about the electron volt. How you convert the electron volt into joule? 1 electron volt is equals to 1.6 into 10 raised to minus 19 joule. Now let us try to understand about the calorie and joule relationship. 1 calorie is equals to 4.186 joule. Now let us try to understand about 1 kilowatt hour. 1 kilowatt hour is equals to how many joules? 3.6 into 10 raised to 6 joule. So these are the some points you have to know, the relationship between joule, erg, relationship between electron volt and joule. So you have to know these all points related to the convergence. Now let us try to understand positive, 0 and negative work done. We have already seen the formula of work. Work is equals to force into displacement. It is a scalar quantity, so we can write it F as cos theta. The work done is a positive if the force, or you can say the component of force, act on body in the direction of its motion. Here they have given theta when it is lies in between 0 to 90 degree. So here we have taken a one block here. So you will see what happened. If you will see Fs, they are acting what here? In same direction, they are parallel here. So the force acting here, it is parallel. We have already studied that work done by the parallel force. What you have to take here? Theta. Theta is 0. So cos 0 is 1. So W is equals to what you can write? F into S. So here you have to know, we have taken theta is 0. Now in this case the work is positive, work done is positive. Now let us try to understand when the work done is 0. If the force act on body in the direction perpendicular to its motion. So here theta you have to take it is 90 degree because it is parallel to its motion. Now let us try to understand, that is W is equals to F into S into cos theta. Theta is a 90 degree here. So what is a cos 90? It is a 0. So work done is a 0 in this case. Now let us try to understand the work done is negative. negative. So theta is lies in between 90 degree to 180 degree. So let us try to understand about this diagram. Here you will see F and S, they are in opposite direction. So we have taken theta is what here, 180 degree. W is equals to F into S into cos theta. Theta is a 180 degree, cos 180 degree, it is what, minus 1. So you can put it, W is equals to what you will get, minus Fs. So work done is what, negative in this case. So this is about the work done. We have discussed that the work, it may be positive, 0 or negative also. So we have studied some examples also related to the work. So convergence also you have to know. So solve the example 6.3 and 6.4 from your textbook. Thank you.